Can we multiply and divide radical expressions? Yes, if the index is the same. If the index is not the same, then no, we may not. So let's go ahead and look at some examples. Can we multiply the cube root of 4 times the cube root of 5? Absolutely. They both are cube root. So I simply take the cube root of 4 times 5, and my final answer there is cube root of 20. Now, if I could simplify that any, I would, but I can't. Next, square root of 2 times square root of 3. You got it. Square root of 6. Ooh, square root of 2/3. What can I do there? Well, I can separate the numerator from the denominator. And it looks like we're about done, except tradition is we don't leave radicals in our denominator. So I need to clear that denominator of the square root of 3. I multiply by a creative form of 1. Now, if I want to clear a square root, how many things do I need? 2, because if I have the square root of something squared, those will undo each other. So in this case, I want my creative form of 1 to be square root of 3 over square root of 3. That leaves square root of 6 over square root of 3 squared. I wrote it that way to emphasize that we must match the index of 2 to the power of 2. Final answer, square root of 6 divided by 3. Go ahead, start on D. All right, did you rationalize the denominator? Now, wait a second, what did you multiply by? Creative form of 1, right? So cube root of 5 over cube root of 5. However, did you catch yourself? I'm taking a cube root, so I don't need 2 5s. I don't need cube root of 5 squared. I need cube root of 5 cubed. So I already have 1 5. I need 2 more. And if that's what I need, then my creative form of 1 has to be the cube root of 5 squared over the cube root of 5 squared. Now I have cube root of 4 times 5 squared is 25, times 4 is 100. And of course, I cleared that radical from the denominator. The cube root of 5 cubed is just 5. Sometimes you get going too fast and somebody's like, oh, 100 divided by 5. But wait a second, 5 is not in a cube root, so you cannot divide those out. You practice on the next 4.
Let's check your work and see how you did. Well, the first one had different indexes, so we knew not possible right away. As I look at number 2, this one, when I multiplied the radicals together, I got the cube root of -8, no big deal, but they both had a coefficient in front of them, a 5 and a 3, so I can just multiply those as well and get 15 cube root of -8, and then I know that that's just -2, so 15 times -2 is -30. Same thing kind of happened in the next one. I had coefficients again, so I multiplied those as well as what's in the radical. I got the 5th root of -10. I can't simplify that anymore. So -2 times the 5th root of -10. And the last one, different indexes, so not possible. Next, let's simplify some radical expressions. We've done this, so why don't you go try them first? So for the square root of 24, I've got 2 root 6, right? It's a square root, so I'm looking for things squared. Well, the only thing I could get squared is the 2 squared, so times 6, so 2 root 6. In B, same thing kind of happened to me. I'm looking for cubes because this one's a cube root. Well, I could get 2 cubed, but times 3, I can't get a cube there. So I can pull out that 2, cube root, 3 left behind. For number 5, I'm looking for cubes again. So I have this 54, well, 27 times 2 is 54, and then x to the 5th, I'm looking for cubes. So x to the 3rd times x squared, because 3 plus 2 is 5. So here I can write 3 cubed times 2, there's nothing I can do with that, times we already have the x cubed times x squared. Now I can take the cube root of things that are cubed. So I get 3x times the cube root of 2x squared. Okay, last one's a cube root again, so I'm looking for cubes. Well, 128, 64 times 2, and then x to the 7th. Well, I could get x to the 3rd times x to the 3rd, that's 6 of them, and then times x to the 1. So final answer, I'm going to get 4. X times x is going to be x squared times the cube root of 2x. Looking at 7 and 8, a big question we need to ask ourselves here is, do we need an absolute value, right? Even index, absolute value. So looking at number 7, I know I'm going to need absolute value bars when I start to simplify this one. It was multiplication, I had the same index, so I went ahead and multiplied all my values together. Sweet, so I've got the square root of 63 x to the 4th y to the 6th. Now it's time to simplify. Absolute value bars needed. So since this is a square root, I'm looking for squares. So 63 is really 9 times 7, so that 9 could be 3 squared, and then I've got x to the 4th, so x squared, y to the 5th, y squared, y. All right, now it's time to take my square root absolute value bars. 3, I can bring out x squared, so that's x times x. Y squared, so y times y. And left in my square root, I'm gonna have 7y. So I get a positive 3 x squared, y squared, square root of 7y. I don't really need the absolute value bars, right? Because I already have a positive 3. X squared is guaranteed to be positive because it's squared. Same with the y squared. And the square root of 7y has to be positive. So same deal for the next one. We're going to need some absolute value bars. Why don't you go try to multiply, then simplify? All right, so let's see what we got here. I got 5 absolute value x cubed y cubed times the square root of 2y. In my absolute value bars, I kept the x cubed because I know that needs to be positive, and then I also kept the y cubed because I also know that needs to be positive. But since there's a y left in my radical, I kind of guaranteed the y is going to be positive, so I technically didn't need the y cubed in the absolute value bars.
I'm taking the square root of the numerator and the square root of the denominator. So it's often easier to rewrite it as the square root of a single fraction, simplify that fraction, and then simplify from there. So you'll see I went ahead and did that. 18 divided by 2 is 9. And then, do you remember how we do this? Yes, we can do subtraction with the exponents, but we can also say we have 5 x's on top, 3 x's on bottom. How many divide out? 3 of them divide out, leaving 2 where? Top or bottom? Top. Square root of 9x squared? Piece of cake, 3x. However, what about absolute value? Will I be guaranteed to get a positive answer here? I better throw some absolute value bars around that x at least. Go ahead and give 10 and 11 a try. Come back and check answers. Number 10 is a cube root, so we didn't have to worry about absolute value. 3y cube root of 2, and then 11 was very much similar to 9, and we get 5 absolute value of x. Next, let's look at rationalizing denominators. We've already seen this a few times, but let's practice again. So if we want to rationalize this 5 divided by root 3, well, that's square root, so I need 2 3's in order to clear the square root. My creative form of 1 will be square root 3 over square root 3, multiply, and then simplify. Gets a little trickier on number 13 because now we're doing a cube root of 7. Notice that the index of the numerator is a square root, so we can't simplify that altogether, and we have to keep them separated. If I'm trying to clear a cube root, how many of those 7's do I need? I need 3 of them, right? How many do I have right now? Cube root of 7. I have 1. That means I need 2 more. So my creative form of 1 will be cube root of 7 squared. If I multiply the bottom by that, I have to multiply the top by that. Let's simplify. Square root of 2, I can't combine these because then it's times cube root of 7 squared. Well, I can go ahead and say that that's 49. For emphasis, I wrote that denominator out as cube root of 7 cubed, so you can clearly see that I have to have the same index and the same power in order to clear the radical in the denominator. I really like 14. See if you can do it. The key here is recognizing that we need 5 y's in order to clear that 5th root. And I already had 2, so I needed 3 more. So my creative form of 1 is going to be the 5th root of y cubed divided by the 5th root of y cubed. And then, once again, for emphasis, how does it clear that radical in the denominator? Because we have the 5th root of y to the 5th.
15. Whew. We got a couple of things going on here. Why don't you simplify before we do anything else? All right, so once I simplified my fraction, I was then able to simplify my radicals, right? So the numerator, I have x times the cube root of x, and then the denominator, I have 2z times the cube root of y. Oh, wait, I left a cube root in the denominator. So that means I'm not done yet. What do I need to do now? Rationalize. Okay, these are cube roots. So how many y's do I need to clear that cube root of y? 2 more. So my creative form of 1 here is going to be the cube root of y squared. So in the numerator, I have x times the cube root of xy squared. And in the denominator, I've got that cube root of y cubed. That's now just going to be y. So I have 2z times y.